Hi, I'm Rob, and I'd like to welcome you to this video on pandas in the Python for Data Science and Machine Learning playlist on the Cumulus Cycles channel. Before we get started, I want to mention that this video assumes you have some prior experience working with Python. If you're new to Python or need a refresher, I recommend watching the Python Fundamentals video in this playlist. Okay, with that out of the way, let's look at pandas. Pandas is a powerful and flexible, easy to use, open source data analysis and manipulation tool built on top of the Python programming language. A key component to working with pandas is the data frame. A data frame is a two-dimensional labeled data structure similar to a spreadsheet or a SQL table, and that's where we'll start in our code. To get started with pandas, first install it and then import it. Now here I've created a variable named data. It's a Python dictionary with key value pairs. I'll call the DataFrame method on pandas, passing it data to create a variable named df, which is a pandas data frame. Then I'll display some information about the data frame. So let's go ahead and execute the code in this cell. And calling df info gives us the data frame info, where we see we have a pandas data frame. It has 4 columns: car, miles per gallon city, miles per gallon highway, and year, with 5 elements in each column. Looking back at the dictionary, we see the columns are derived from the keys, and the elements in the rows are derived from the values. Looking back at the output, we see that the data type for the car column, which contains strings, is of data type object. The others are int64 as they have integer values. Calling df shape on the data frame tells us the data frame has a shape of 5, 4, which represents the 5 elements in the 4 columns. Calling toList on the data frame columns presents a list of the column names. Printing the data frame will give us the first 5 rows, and calling describe provides summary statistics on the data in the data frame. Now in this next cell, I'm going to call the readCSV method on pandas to load data from the automobile data CSV file into a data frame. So let's take a look at that CSV file real quick, and we see there are multiple rows of data for several columns. So after I load the data, I'll once again call dataframe info as well as the other methods to show the data on the data frame. Here we see we once again have a pandas data frame. There are 94 entries. Here are the list of columns and data types. It has a shape of 94:9, and again the list of columns. This time, instead of just printing the data frame, I'll call the head method on the data frame passing 3 to get the first 3 rows. And I'll pass 3 to the tail method to print the last 3 rows. And here are some summary statistics on the data. An important skill to have when working with data frames is filtering. Filtering allows us to access data in the data frame based upon specific criteria. So here I've declared a variable automake, and I'm setting it equal to the make column in the data frame. Then I'll call head on automake and print the results. And we see the first 5 values in the make column. Here, once again, I'm accessing the make column in the data frame and calling head on it, asking for the first 10 rows, which we see here. In this cell, I've declared a variable mpg filter and set it equal to the miles per gallon column in the data frame, and I'm looking for rows with the miles per gallon column value greater than 20. Then I'll pass the filter into the data frame and print the first 10 rows, which we see here. Now, looking at the output from the cell above, we'll see the fuel type column has several different values. So there are autos that run on petrol, electric, and hybrid. So in this filter, I want to access the rows in the data frame with the fuel type equal to petrol and the miles per gallon column greater than 20. Once again, I'll pass the filter to the data frame and print the first 10 rows. Now we see our results only contain rows with the fuel type equal to petrol and miles per gallon greater than 20. In this cell, once again, I'll get rows with fuel type of petrol, miles per gallon greater than 20, and the year of the car greater than or equal to 2020. In this final example, I'm setting the filter equal to rows which have the price column greater than 150,000 but I'm filtering on the existing filtered data frame. So I've already filtered down for fuel type equal to petrol, miles per gallon greater than 20, and year greater than 2020, and I'm adding a price filter. So when we run this code, we see we have 3 rows in the data frame which match the filter criteria. Another important skill to have when working with Pandas is cleaning data. As an example, I'll import Pandas and then once again read the data from the automobile data CSV file. And before we load this, let's jump back into the CSV and take a look at the data. So first of all, we'll start with the headings. Here we have make with a capital M, model with a capital M, miles per gallon has spaces in it, engine size is lowercase and has a space. Looking at the data, we see a row that's completely empty. Here's a row that has not a number as a value for the price. And we see additional rows with similar issues. So let's go ahead and load the data into a data frame again. And what I want to do now is make some modifications to the headers so that they're consistent. Ultimately, I'm going to change them all to lowercase. I'll replace the spaces in the titles with underscores. And I'll rename miles per gallon to MPG and engine size to displacement. So I'll start out by getting the data frame columns and storing them in a list. Then I'll call string to lower and string to replace on the columns in the data frame and replace the spaces with the underscores. Once again, get the list so we could see the change. And then I'll call rename on the data frame, renaming miles underscore per underscore gallon, which we changed from miles space per space gallon to MPG and engine underscore size to displacement, and then display the list. So let's execute the code in the cell. And here we see our original list of column names, some with capital first letters, spaces into miles per gallon, and engine sizes lowercase. After the first conversion, we see the names are all lowercase and the spaces have been replaced with underscores. And the final updated column list has miles per gallon replaced with MPG and engine size with displacement. Now let's go ahead and print the data frame. We see our column names have been updated. Here are the first 5 rows. And here are the last 5 rows. Now let me scroll back up and I'm going to comment this print statement out and uncomment calling toString on the data frame, and we'll see what that looks like. And here we have a nice view of the data. Now in this cell, what I'm going to do is call the drop method on the data frame, passing a filter looking for fuel type of electric or hybrid. And then I'm going to drop those columns from the data frame. And this will be an in-place execution. I'll just perform the operation in place and modify the data frame. Before I execute the drop, I'll print the number of rows in the data frame and again after so we see the difference. Then I'll drop the mileage column and provide the final updated list of columns. So let's go ahead and execute this. And we see the number of rows in the data frame before dropping electric and hybrid vehicles is 94, and after there are 80 rows. Here's the updated column list, which no longer contains mileage. In this cell, I'm passing a filter looking for any rows in the data frame that are completely empty. So going back to the data, for instance, this row is completely empty. And then I'll print the rows. I'll print a count of the empty rows before dropping them by calling drop NA on the data frame. The how says look for rows in the data frame that have all empty values in the cells and do this as an in-place execution. Then I'll once again look for empty cells and print the results. So let's go ahead and execute this. Here we see we have 3 rows in the data frame that are completely empty. There are 80 rows in the data frame before dropping those rows. And we see the starting 80 matches the ending 80 from the cell above after we dropped electric and hybrid vehicles. After dropping the empty rows and looking for them, we see they're no longer in the data frame. And after that execution, we now have 77 rows in the data frame. Now this cell is going to find and drop all rows that have empty values in any of the columns. So let's execute this. And we see that these 7 rows all have not a number in the price column. So before dropping these, we have 77 rows, which matches the end result from the cell above. After dropping, we see we no longer have any rows with empty cells, and there are now 70 rows in the data frame. Finally, I'll look for duplicate rows in the data frame by passing the data frame duplicated filter to the data frame and then do an in-place drop duplicates on the data frame. So let's execute this. So we see our data frame has 3 rows that match existing rows in the data frame. Before removing the duplicates, we have 70 rows, which matches the result of the prior cell. And after removing those 3 duplicates, we have 70 rows in the data frame. This final example will show a correlation matrix of the columns in the data frame. To get started, as usual, I'll import Pandas. I'm also importing matplotlib and Seaborn to plot the matrix. This time, I'll read the data in from a Kaggle Automotive Data CSV file, which if we take a look at that, we see multiple rows with multiple columns with mixed data. So I'll go ahead and read that data into a data frame, print the info. I want to drop the symboling column and then print the head. So we see there are 205 rows in that data frame with 26 columns. And after printing this info, I dropped the symboling column and then printed the head. And we see the data frame starts with the normalized losses column and not the symboling. Now I'm going to call the correlation method on the data frame looking for columns that only have numeric values, and then I'll print the correlation matrix, which we see here. Then finally, I'll use this code to display a heat map of the correlation matrix. So that concludes this introduction to Pandas. If you found it useful, feel free to give it a like. And if you'd like to be notified when I add more content to the channel, please consider subscribing. Thanks for watching.